All right, so we have quotients of expressions involving exponents. If I write this out the long way, if I have b to the sixth, b to the sixth means I have a b times 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 another b, right? So I have b to the sixth a on top of my fraction. On the bottom, I have b to the fourth, b times b times b times b, and a to the seventh. 1, 2, 3, 4, 5, 6, 7, if I get them all there. So what I'm ending up doing is that I'm canceling out the common factors on my top and the bottom of my fraction. So if I look at this, how many of those b's can I cancel out of there?
You mean how many of them are the same?
Yep.
Okay, so then 4.
I cancel out 1, 2, 3, 4 of them. And how many a's can I cancel out of there?
1.
Just one of them. So what I end up with is b to the second over a to the sixth, right? Now I obviously don't want to have to write all those a's and b's out. What if I had 15? So if you look at that and look for a shortcut, here's what you're really doing. You're saying I have 6 b's on top and 4 b's on the bottom. I can cancel out the smaller amount. I can cancel 4 of them out of there. So I'm going to take out the smaller number from 4. 6 minus 4 gives me 2 up on the top, right? With the a's, I've got 1 a on top and 7 on the bottom. I can only take one of them out because it's only going to have 1 in common. So I take the 1 off the top. If I take 1 off the bottom, it leaves me a to the sixth on the bottom. So my rule is that when I divide, I'm subtracting my exponents. I'm taking the small one away from the bigger one, and the variable is going to stay where you had the bigger exponent. So if the bigger number was on top, my variable stays on the top. If it was on the bottom, it'd stay on the bottom. So if I have b a to the seventh over b to the fifth, a to the fourth, on my b's, how many b's can I take out of there? Just 1. I have 1 in common on the top and the bottom, so if I take the 1 off the top, it's going to leave me b to the fourth on the bottom. With my a's, how many a's can I take out of there?
4?
4, right? We've got 7 on top, 4 on the bottom, so I can take off 4. Leaves me a to the third on top. So my answer is going to be that I have a to the third over b to the fourth.
Wow.
So, number 3 then. I have y to the third w to the sixth over y to the fifth w to the sixth. What do you think is going to happen there?
Well, we're going to have y to the second.
And where's it going to end up? On the top or the bottom of my fraction?
Bottom?
On the bottom. I'm going to take off 3, which leaves me an extra 2 down on the bottom. What happens with the w to the sixth?
They're 0.
It's not 0, it's actually 1. Anything divided by itself is 1. Right? I'm
Okay.
saying this goes into here once and this goes into there once.
Okay.
Okay, they cancel each other out. It looks like it's 0 when it's gone, but it's technically 1.
Okay.
So, on top I'm getting,
W.
not w,
1.
1. And on the bottom I'm getting
Y2.
y to the second power. Which is going to lead me into my next rule. If I just think about what we just did, just with the w to the sixth. W to the sixth divided by w to the sixth, we said we know is equal to 1 because anything divided by itself is 1. But if we follow our rule said if we do w to the sixth divided by w to the sixth, we subtract those exponents. And when you do 6 minus 6, you get 0. So, by definition, anything to the 0 power is really equal to 1 because it means you divided something by itself. So, I'm going to have you grab your calculator. just to test out this theory. If you do 3 caret 0, 3 to the 0 power, what do you get?
1.
You get 1. If you do negative 10 caret 0, what do you get?
1. Negative 1.
Whoops. We probably have to do this then to make it go right. If we got negative 1, we don't want negative 1. We better put parentheses around it. Negative 10 in parentheses caret 0.
Caret 0 equals 1.
There we go. Probably the same thing with a fraction. We probably better put the parentheses around it. If you do 2/3 to the 0 power, put your 2/3 in parentheses, what do you get?
Well,
So everything we typed into the 0 power, provided we typed it in correctly with the parentheses, it gives you 1. So by definition, anything to the 0 power is equal to 1. We are now going to evaluate some things that have to the 0 power in them. So when we follow our order of operations, we have to do the exponent first. If I do 3/5 to the 0 power, 3/5 to the 0 power is 1, right? So now I have 2 times 1. 2 times 1 is just going to give me 2 then. And again, if you wanted to check that with your calculator, you would punch it in 2 parentheses 3/5 to the 0 power.
huh.
You get 2, right?
Why is that now? Because there's 2 different numbers there?
Because this part of it that's to the 0 power is equal to 1, and then you got to multiply it by the 2 that's in front. 1 times 2 is 2. So, we're going to practice some. If you do negative 2 to the 0 power, what's my answer going to be?
1.
1. Number 5, if I do 3 times negative 8/9 to the 0 power,
Well, that's going to be 3.
it's going to be 3, because that's 1, and 3 times 1 is 3. How about minus a negative 4 to the 0 power?
I don't know. Will it be negative 1?
It will be, because this part of it's equal to 1, and then the minus is in front, so it's negative 1. So number 6, minus 3 to the 0 power.
1. Negative 1.
Negative 1, because the negative's on the outside of the parentheses. So if it's on the inside, it stays positive, but if it's on the outside, it's going to be negative. And on the bottom one,
Negative 3 times 1, negative 3.
is negative 3, exactly. So it doesn't make a whole lot of sense, and it's an easy thing to forget, but anything to the 0 power equals what?
1.
Yep. The next weird rule has to do with negative exponents. So going back to that division thing we were doing, if I have x to the 2nd divided by x to the 4th, when we simplified that, we said that we subtract our exponents, right? We said, oh, this is going to cancel out, this is going to be x squared, but we know that there's a 1 up there, so we got 1 over x squared, right? Remember doing those ones? We just did them up on the above ones. Now, our rule says we subtract our exponents, so if we follow our rule, x squared divided by x to the 4th would be x to the 2 minus 4. If you do 2 minus 4, what do you get?
2.
You get, not 2, but
Well, x squared.
x to the 2 minus 4 is
Oh, negative.
negative 2. So, by definition, x to the negative 2 is equal to 1 over x squared. I could write. What that negative exponent does is it does the reciprocal. So, if I have a negative exponent and I'm trying to evaluate this expression, to get rid of the negative exponent, I'm going to do the reciprocal of the base. There they come. So, the reciprocal of 8/3 would be 3/8. That makes my exponent positive instead of negative. Since this one's to the first power, it's just going to be 3/8. Now again, we could check that with our calculator because our calculator knows all this math. If I do 8/3 caret -1, what does your calculator give you?
3/8.
3/8. So, if I have a negative exponent, the first thing I'm going to do is do the reciprocal of the base to make that exponent positive. So, if I have 7/6 to the -2 power, the reciprocal of 7/6 would be 6/7, and that makes it a positive 2 instead of a negative 2. And on this one, then I have to square. 6 squared is 36, and 7 squared is 49. So again, if we were going to check that with our calculator, we would do 7/6 to the -2 power. Go ahead and punch that in.
Parentheses.
Yep, parentheses. We found we needed the parentheses on our calculator.
36/49.
Okay, that's what we got. So, number 9, we want to rewrite that without that negative exponent and simplify that. So what should we do first?
4/3.
Make that 4/3 to the third power. And so now we're going to figure out our 4 to the third and our 3 to the third.
64.
64 over
27.
27. Now what happens with this one when you do this one on your calculator?
Oh, it goes to the mix.
It gives you the mixed number, and how do you change it from the mixed number to the fraction? Shift and the fraction button, yep.
64/27.
So because it was an improper fraction, the calculator gives you the mixed number first, and then you'd have to change it to your improper fraction to double check, and sure enough, we got the same answer. So, negative exponent, we're going to do the reciprocal of the base to get rid of it. So now we're going to do some where we have a whole number base. Well, what is the reciprocal of a -9?
1/9.
1/9, negative 1/9, because that sign's not going to disappear, right? I'm going to write it like this, because -9 is really -9 over 1, so the reciprocal would be 1 over -9. I'm then going to square that. Now, if you look at the Alex thing, they're only going to put the squaring by the -9, because 1 to any power always stays 1, and they know that. Technically, the whole thing is squared, but 1 squared is 1, so they just leave it off of there because they know it's supposed to be 1. So when you look at their explanation and they do that, that's why, because they know it's going to be 1. If I take -9 and square it, what am I going to get?
-81.
Negative times a negative? Positive 81, right? When you take -9 times -9, you get a positive 81. So again, if I wanted to check that with my calculator, I use the parentheses around the -9 to the -2 power. Go ahead and punch that one in.
Power is
Did you not get it typed in there right, or what was that
I
look?
thought I did.
-9. Oh, what in the heck? Why is that coming up as a decimal and not a fraction? Well, let's put it as a fraction. I don't know why it came up as a decimal unless you got your mode switched. Let me switch your mode back into normal mode. Now try it. Unless you use the dividing instead of the fraction. Maybe that's what you did. Did you use your fraction button or did you use the dividing
I
button?
used my fraction.
Okay. Still coming up as a decimal?
Mm-hmm.
Hit shift in the fraction button then.
Fraction.
See, good thing we try these things out. So if you do get the decimal like you are, then you have to do shift in the fraction button to change it into the fraction instead of the decimal. For some reason the calculator wants to default into a decimal because we're working with a whole number to start with, I'm assuming. So, number 11, if we go on top the next page there, we want to do -8 to the -1 power. First of all, getting rid of the negative exponent, we would do the reciprocal of -8, which would be 1 over -8. That's going to make that to the first power. So if it's to the first power, you're just going to get -1/8, right? Again, with fractions, if I do have a negative, they don't like the negative on the bottom, they'll put the negative in front of the fraction instead of down in the bottom of the fraction. If you put it in the bottom, it'll just say, it's correct, however. So number 12, if I want to do -4 to the -3rd power.
1/4. -1/4.
1 over -4 to the 3rd, right? Or -1/4 to the 3rd, which gives you -1 over 64. So, now that they've maybe tried to get across the point that to get rid of that negative exponent you have to do the reciprocal, they want you to understand that if there's not parentheses, that negative exponent only goes with the variable. This means 3 times m to the -2 power. And to get rid of that negative exponent, how would I write m to the -2 power? Using a positive exponent. In other words, what would be the reciprocal?
1m.
1 over m squared, right? So this would be 3 times 1 over m to the 2nd power. Well, if I put that all together then, I just end up with 3 over m squared. So what they're going to tell you on Alex is, if my negative is on the top of the fraction, to make it positive, I'm going to move it to the bottom of the fraction. If it's on the bottom of the fraction, to make it positive, I'm going to move it to the top of the fraction, because I'm doing the reciprocal. So if my negative is on the top, I move it to the bottom. If it's on the bottom, I move it to the top. That's if it's an exponent. So here, I have 1 over -5z to the -4. This part right here, the z to the -4, is what I want to get rid of out of my expression because I want to have no negative exponents. Since it's on the bottom, I'm going to put it up on top. So I would have 1z to the 4th over -5. Of course, I want to rewrite that in a better form than that. I don't really need the 1 in front of my z to the 4th, and the negative is going to be out in front of my fraction. So the better form for that answer would be -z to the 4th over 5. So, number 15 then, I want to rewrite that expression without that -z to the -2 power. So how would I rewrite that expression?
4 over z squared?
You forgot one little thing on that.
-4.
It's a -4 over z squared. Again, they'll put the negative in front instead of on top, because if the top is negative, the whole fraction is negative. So this came down, went underneath my 4 because it was negative. We're going to use that some more when we simplify 16, 17, and 18. These ones look like ones we did the other day, only now we have negative exponents. We said when we did these, we are going to start with multiplying our coefficients. So -9 times 5 times 2. So if I multiply that together, I'm going to get -90, right? Then I'm going to do my like variables. I have a w, that's just a plain w, and I have a w to the -3rd. W times w to the -3rd. We said on the previous page, when we multiply, we have to add our exponents together. W is w to the first power. 1 minus 3 then would give us w to the -2 power. Then I've got some u's. U to the -6 times u to the 6th. U to the -6 and u to the +6. What happens there? -6 and 6 would give me
0.
0. And u to the 0 power is equal to 1. I don't really need to put the 1 in there because 1 times my -90 is going to be -90. So I can just think of it as it's canceling each other out, right? -6 and +6 gives me 0. And then I have some x's. I have x to the -6 and x to the -2. So -6 plus a -2 would give me -8. So I've got everything combined, but now I want to simplify it without using that negative exponent. So how would I want to rewrite my answer so that I don't have those two negative exponents? Thinking about what we did up here.
-90 over?
-90 over w to the 2nd and x to the 8th. Because when I move them down to the bottom, it's going to make those exponents positive instead of negative. And again, they'll put the negative in front of the fraction instead of on top. It's just a picky thing. But that's how my answer would then end up looking. So number 17, same kind of thing. I'm going to start with my coefficients, my numbers. So I'm going to take 7 times 2 times 6. $84. Your variables, it really doesn't matter what order you go in. I just usually go in the same order the problem had it. So I'm going to do my x's first. I have x to the -6 times an x to the 7th. I get just an x, right? X to the first, which is just x. Then I got some u's. I've got u to the -2 and a plain old u.
U to the -1?
Exactly, u to the -1, because I take -2 plus 1, which is -1. And then I've got some v's. I've got v to the 4th and v to the 5th. V to the 9th. Now I want to write my answer with only positive exponents, so I need to get rid of that u to the -1. How should I write my answer?
84x v9 over u1.
or just u, because u to the first is just u. Why didn't I move the x and the v to the ninth?
Because they're not
Because
negative.
they were negative. The only one I moved was the one with the negative exponent, and probably in introductory algebra, if you put u to the first, it's going to say it's correct, however, but once you get further on, it's going to start counting that wrong. U to the first is just a u. We don't need the 1 there. I write it there when I'm doing my calculations to remind me, but on my answer, I don't want the 1 there. So that'd be my answer. So, last one on this page, number 18. How should I do that one?
Two times 8 times 4. 64.
64. Then what are you going to do next?
W to the negative 3. W to the 8.
Gives you
Negative, no, 5.
positive 5. Negative 3 plus 8, positive 5. Then I'm going to do
V.
v to the,
V6 to V6.
which would give me
V12.
v to the 12th, exactly. And then I'm going to have x to the negative 1 times an x, which, what happens with that? Is 0, x to the 0, which cancels that out of there, right? On this one, we don't have any negative exponents, so our answer is just the 64, w to the 5th, v to the 12th. I don't have to move anything to the bottom since I didn't have any negative exponents. All right. I believe that's the end of that page. So that should be the next 6 things.